This podcast is about the quadratic formula. The quadratic formula is used to find the solutions or the roots to a quadratic equation. A quadratic equation is in the form of ax squared plus bx plus c equals 0, where a, b, and c are real numbers, and the other restriction, a cannot be 0, otherwise it would not be a quadratic equation. To use a formula, the quadratic equation has to be in this form. If it's not equal to 0, you may have to rearrange your terms. So the quadratic formula is x equals the opposite of b plus or minus the square root of b squared minus 4ac all divided by 2a. Again, this formula gives you the solution to the quadratic equation. So if we take example 1, find the solution to the quadratic equation, we can see that our equation is already solved for 0. 3x squared minus 2x minus 1 equals 0. And if you note how we wrote it on the last page, a is the coefficient of the x squared, b is the coefficient on the x term, and c is a constant. And so in this problem, a is 3, b is negative 2, and c is 1. If I put those values then into our quadratic formula, which is listed on the right, I will get x equals the opposite of negative 2 plus or minus the square root of negative 2 squared minus 4 times 3 times negative 1 all divided by 2 times 3, which gives us positive 2 plus or minus 4 plus 12 over 6, which is 2 plus or minus the square root of 16 in the numerator, and the square root of 16 being a perfect squared will be 4. Continuing, if I separate those two solutions, one solution is 2 plus 4 divided by 6, and the other solution is to subtract 4 divided by 6. And so my two solutions are x equals 1 or x equals negative 1/3. These are the values that I could put back into the original problem to make it equal to 0. Because they are nice numbers, rational numbers, it tells you that this quadratic equation could have been factored, and I could have used the zero product theorem to find the solutions. If we'd like to check our answer to see if it's correct, if I put our two solutions back into our quadratic equation, it should make a true statement. So first of all, if I put a 1 in for x, I get 3 times 1 squared minus 2 times 1 subtract 1 equals 0. And I get 3 subtract 2 minus 1 equals 0, and 0 equals 0. That tells me that x equals 1 is indeed a solution to our quadratic equation. And second of all, I'll put negative 1/3 in for x. And I get 3 times negative 1/3 squared minus 2 times negative 1/3 subtract 1 equals 0. Simplifying, I get 1/3 plus 2/3 minus 1 equals 0. And 1 minus 1 equals 0, and 0 equals 0. So again, I have shown that the second point indeed is a solution to our quadratic. Here's example 2. And in example 2, instead of our solutions being rational, our solutions in this case will be irrational. Again, we first have to find our values of a, b, and c. And in this problem, a is 1, b is 4, and c is 2. Again, listed off to the right is our formula we're using. And so we get x equals the opposite of 4 plus or minus the square root of 4 squared minus 4 times 1 times 2 over 2. And under the radical, that will be 16 subtract 8, which is square root of 8. Now we do need to simplify that square root of 8, and the factor of 8 that's a perfect square is 4. So if you remember, we're going to rewrite that as square root of 4 times square root of 2, which is 2 root 2. And you can see that I have replaced the square root of 8 with 2 root 2. In my last task, can I simplify that? Well, I have a 2 in the denominator, and I look in the numerator to see that 2 is also a common factor in the numerator. So I factor the 2 out of the numerator, and then I have 2 divided by 2, which is equal to 1. And so my solution is x equals negative 2 plus or minus the square root of 2. That is a irrational number, or two irrational numbers. Again, if I would like to check that answer, I again could put that value of x into my quadratic, and I've chose just to take the one of the solutions, negative 2 plus root 2, and if I put that into our quadratic, I'd have negative 2 plus root 2 quantity squared plus 4 times the quantity negative 2 plus root 2 quantity plus 2. I'm going to have to FOIL out the first term. And in the third step, I have actually FOILed the first term distributed in the second term. Last of all, I did rearrange. Now you would not have to do this physically, but if you took the um, rational numbers and then combined the irrational numbers, you can see that they do combine into 0. And so again, I get my 0 equals 0, which does prove indeed that that is a solution to this quadratic equation. Hopefully this has helped you review the quadratic formula, and this ends the podcast.